Hello, everybody. This is Mr. Bing. It is February 26, 2021 at 12:01 p.m. And I am in Project Lead the Way, Principles of Engineering. And the problem that I want to go over is in the 1.2.3 electric circuits assignment, the SIM. And so you should be able to find that if you start at the Schoology, not the Googly, the Schoology course page. Start here, Project Lead the Way course page. There it is. That is the assignment. And within that assignment, there is a resource called Introduction to Electricity, which I've asked everybody to read and take notes on, all kinds of clickable notes here. And part of this assignment that I've asked them to do, or part of this resource that I've asked them to look at, is to solve a couple of these circuit problems. There's a series circuit problem that has to be solved. And by the way, in case you want to know, Project Lead the Way does show you that solution. You can use that for a guide. And then the second one is the parallel circuit. And of course, Project Lead the Way shows you that solution. You can use that as a guide. But the idea is that you do it by yourself. You do it on your own. I have looked at it, I admit, but then I also tried to do it myself. And that's what this video is all about. So you see the schematic, and there is a voltage, a battery given right there. That's 15 volts. And then a resistor and a resistor and a resistor. And all the values are given there. There's different unknown quantities. And so that particular schematic I put into here, onto my engineering notebook. And so you see it's POE 1.2.3 SIM, electric circuits. And this is from the Introduction to Electricity resource, which is that. And it's figure 13 parallel circuit example, which is that, figure 13 parallel circuit example. And notice that I recreated the schematic. You have to recreate the schematic of every one of these circuit problems. And if you're doing a simulation, you have to take screenshots of that too. And I hope you notice that I got the V sub T, the total voltage at the battery is 15 volts. I got that from here. And then the resistance, R sub 1, first resistor, R sub 2, second resistor, R sub 3, third resistor. Those values are 470 ohms. That omega, that uppercase Greek omega represents ohms. 470 ohms for the first one, 2.2 kilo ohms for the second one, and 3.3 kilo ohms for the third one. There is a current I sub T that is unknown. That'll be an issue. So you've got voltage, 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 4 voltages. You have resistance, 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 3 resistances. You've got a current, but it turns out that there's a lot more to it than just those things. I wrote down the given here. V sub T, R sub 1, R sub 2, R sub 3, 15 volts, 470 ohms. Notice I changed the kilo ohms to just straight up ohms because I don't want to forget about those values. 2200 and 3300 for those two values. And so whenever you are solving a circuit, I'm air quoting right now, whenever you are solving a circuit, it means that you find everything in the circuit. So it's not like, oh, just find the total resistance. That's one small part. Solving the circuit means find everything. And when I'm looking at this, I see that the voltage and 3 resistances were given, but I noticed that the total current was not given, and the 3 voltages at each resistor were not given. And then the total resistance of the whole thing was not given. Now, I also probably should have written down, and it's too late. It's too late. I probably should have also written down that there is a current at each resistor, which is I sub 1, I sub 2, I sub 3. Even though I did not write them down, I did end up solving them or finding them when I solved the circuit. Solve the circuit means find everything. Okay, so this schematic that I started with the voltage and the resistance and the resistance and the resistance, it's a parallel circuit. However, I simplified that circuit. I compressed it down to the original 15 volt battery, the original I sub T current that's unknown, except I took those 3 resistances and combined them into a total resistance. We have to do this in order to find the total current. So that's first step. Resistance, resistance, resistance. Now the equation for total resistance for a parallel circuit is this sum of the inverses. Actually, it's the inverse of the sum of the inverses is the way that works mathematically. 1 over R sub T equals 1 over R plus 1 over R plus 1 over R plus 1 over R plus 1 over R forever for however many resistors you have. We have 3 of them. So these resistors, R sub 1, R sub 2, R sub 3, we substitute 470, 2200, and 3300. There are some calculator tricks that you can do to make this quicker and easier. However, I'm just going to go a little more straightforward, conventional way. 1 over 470 is that decimal. 1 over 2200 is that decimal. 1 over 3300 is that decimal. So you got those three decimals and you add them together. Notice I made an error here, so I just crossed it out. 1 over r sub t, which is the sum of these three, is 0.002888. I rounded off. And however, 1 over r sub t is not r sub t. You have to invert it. You have to divide 1 by 0.002888, and I got 347. Notice I'm rounding off to approximately 3 or 4 decimals. I'm very sloppy with significant digits, but it does seem to be somewhat consistent. R sub t, now that we know 347 ohms, 347 omega. So with that R sub t, now that we know the total resistance for all three, the total resistance compressed here, and we know the voltage, we can find that total current, which was eluding us so far. Elusive. It was unknown. So we remember Ohm's law, which relates voltage, current, and resistance. And Ohm's law is V equals IR. Notice I added these subscripts, V sub t, I sub t, R sub t, because that's what we're dealing with, the total voltage, the total current, and the total resistance. If you do some algebra here, I sub t ends up being equal to V over R, V sub t over R sub t. The value given was 15. The value that we just found for R sub t is 347. You stick those in, you calculate. Notice I made another error, but I figured it out, and then I wrote 0.0432 amps for that total current, 0.0432 amps. Notice I underline each answer as I find it. Okay, so again, we have to solve the complete circuit. We know the three resistances that we were given. We know the total current we just found. We know the total voltage that was given. We still need the V sub 1, V sub 2, V sub 3. And remember, I forgot to label the I sub 1, I sub 2, I sub 3. So it turns out I looked up in this. Remember this? Yeah, I looked up in there that for parallel circuits, all of the voltages are the same. So this V sub 1, V sub 2, and V sub 3, they're all equal to each other, and they're equal to the total voltage. So that ended up being a lot easier than I expected, that all of V values are 15 volts. Well, now that I know that, I can go back to this Ohm's law, V equals IR. And I can go back to the derivation that I did using, algebra, where I equals V over R, except instead of a T and a T and a T, this time I've got a 1 and a 1 and a 1, a 2 and a 2 and a 2, and a 3 and a 3 and a 3. So I take each of those sets, the set of the I sub 1, unknown, is equal to the V sub 1, which we just found was 15, divided by the R sub 1, which was given all the way up here for 470 ohms. And then I stick that in, do some math, and I get 0.0319 amps for I sub 1. Similar process for I sub 2 using the second resistance. Similar process for I sub 3 using the third resistance. I get these three resistances. Before we celebrate, though, we did a lot of work with at least a couple of errors that I caught, and there could be more errors. How many errors does it take for this thing to go completely down the drain? And that's right, one error will completely screw it up. Thank goodness I caught those. Well, there's a way to check your work, which is if you already know the I sub t, which we do, and we found the I sub 1, I sub 2, I sub 3, the current at each resistor, it turns out for parallel, just like there is a defined relationship for voltage, for parallel, there's a defined relationship for current. And the total current is going to be equal to each individual current, I sub 1, I sub 2, I sub 3, at each individual resistor. And we found that I sub 1, I sub 2, I sub 3. Well, if you know those three, and you plug them in, and you add them together, whatever 0.0319, 0.006682, 0.00455, add them together, you get 0.0433. Well, I don't know if that really means much, except that if I compare what I just calculated the I sub t with the value that I previously, just like 2 minutes ago, calculated the I sub t using a different mathematical relationship, I got 0.0432 amps, and now I get 0.0433 amps. It's a little round off error, which I really don't care that much about. I gave myself a check mark because that appears to be correct. I signed and dated the bottom of my page. Lewis witnessed it with his date. I don't have any team members, except I have the emotional support of everyone in class. I hope that this was somehow useful to you. Subscribe to my channel. Give me a positive comment, like button, bell button. I don't know what else you do. So do all those things. And I'm going to say goodbye now by stopping the recording. And this was pretty decent. Bye, everyone.